The following content is provided under 4D Science Group.
Hi, my name is Michael Warren, and here I'm going to show you an example of integration in Calc 2. The integral you see now can be solved via several techniques. I'll be going over one of them. Of course, before we get started on trying to use our techniques from Calc 2, one of the things we might want to do is, of course, rewrite this as x times x squared over x squared plus 1 quantity squared dx. This suggests, well, you guessed it, a u substitution with u equal to x squared plus 1 or x squared. I choose x squared plus 1 because it makes the denominator and my life easier. I'm going to choose this x squared plus 1 to be my u substitution simply because it makes the denominator and both of our lives easier. If I let my u substitution be either 1, then we have u equal x squared plus 1 du equals 2x dx. It is a constant times this. It would go the same way if u were to equal x squared. And since we don't have 2, we must compensate in our simpler integral by writing a 1/2. And this is because du divided by 2 is just x dx, which is exactly what we got going on here. Now the u equals x squared plus 1. That means that this x squared is equal to u minus 1. And this here is equal to u squared du. Now, there's a couple ways of solving this, but I will choose just splitting it up. And this can be rewritten as 1/2 u over u squared minus 1 over u squared du. And then we simplify here. 1/2 1 over u minus 1 over u squared du. And of course we can split it up into 1/2 1 over u du minus 1 over u squared du. Now here's stuff that we already know how to take the integral of. In fact, this is natural log x, and this is 1 over x, negative 1 over x. So we have 1 over 2 natural log of, and this antiderivative here, if we remember the antidifferentiation for power functions, excluding the case where the exponent is minus 1, we have to add 1 to this exponent, which, by the way, this is rewritable as u to the minus 2. If we were to antidifferentiate this, we get u to the minus 1 over minus 1, which, by the way, is minus 1 over u. But wait, we have a minus here. So this minus here becomes a plus. And this is plus c because it's an indefinite integral. But we're not done. This is not our exact answer. We have to plug back in u equals this function of x. So our final answer is 1/2 natural log of absolute, well, I can ignore the absolute value function here because x squared plus 1 is never 0 and it's never negative. and we're done.